It begins now. Globally to the fellow. Oh, yeah. Good morning to a fellow lecturer and my fellow friends. My name is Sam Yujasin. My register card number is 50DTK21F2011.
Good morning. My name is Krishna Vipani and my metric number is 15DTK21F2001.
Good morning. My name is Adrian Yesudasan. My matrix number is 15DT21F1018.
As of right now, we are doing a role play exercise about this dialogue, and we are going to elaborate the concepts, the usage of the flowchart. And so Tejas is played by Adrian, Jyoti is played by Vipa, and I, Sam, will play Moss. So here we are. We're starting now.
We visited a computer exhibition for school students. We saw a supercomputer demonstration of many uses of computer and many more interesting applications.
In one of the booth, we could enter any number as an input and the computer was displaying the multiplication table of the number shown above. This picture used by the person at the booth to explain the sequence of steps followed by the computer to display the multiplication table. We observed that those who did not know about computers and programming could also understand what was explained by the picture.
This picture is a graphical representation called a flowchart. One of the main uses of a flowchart is to write the sequence of steps and logic of solving a problem before writing the full computer program. It also helps in communicating the steps of the solution to others. So, what is a flowchart? A flowchart is a graphical representation of the problem-solving process. It also gives a step-by-step procedure for solving a problem.
Well, as for the introduction of a flowchart, various geometrical shaped boxes represent the steps of the solution. The boxes are connected by directional arrows to show the flow of the solution problem solving. The main use of a flowchart is to show the sequence of steps and the flow of a computer program. Some of other uses of a flowchart are to communicate a solution to a problem, explain a concept, and show the logic of classification of data, rules, and flow of playing a game.
I see that various geometrical shapes are used in this representation. We are eager to learn about flowcharts.
Let us start with a simple example. Look at the following flowchart of adding two numbers a and b. Let us discuss the problem solution and the geometrical shapes used. So in start, here's the input, read A and read B. A is equals to 845, B is 247. In the process, sum equals to A plus B. Sum equals to 845 plus 247. And here is the print sum, which is the output. The sum is 1092. And here's the end. What do you do when you are given a problem?
First, we identify the goal. Here it is addition of two given numbers.
How do you achieve this goal?
First, we identify the data that is given. In this problem, we have the two numbers a and b, reading their values represented by parallelograms.
Right. What would you call this in computer terms?
Input.
The data or information that is available, which is called input, is represented using a parallelogram in the flowchart. What is the next step?
The next step is to add the numbers, which is called processing in computers.
Correct. The details of processing of data is represented in the rectangle.
The next step is to write the result of the addition, which is output in computer terms. This is also specified in a parallelogram.
Right. A parallelogram is used to specify both input and output in a flowchart. What else do you notice in the flowchart?
And an arrow points from one step to the next step in the flowchart.
In the flowchart, arrows are used not only to connect the steps in the sequence, but also to show a clear flow of the problem-solving process.
Start and also end of flowchart are shown with an ellipse.
A flowchart should give a clear indication as to where the problem-solving flow starts and where it ends. The start of a problem-solving process and the end are indicated using the ellipse.
This is just like using stepwise thinking lesson step by step to solve a problem.
Yes, the step-by-step method of solving the problem is specified using a flowchart. This helps you to be clear about the input procedure and output. It also helps you to communicate the solution. So, in the concepts, the uses of flowchart are specify the method of solving a problem, to plan the sequence of a computer program, and communicate ideas, solutions, etc.
The guidelines of drawing of a flowchart are follow step-by-step thinking and logical reasoning of solving a problem, identify the goal or the solution to be found, think of the sequence of steps for working out the solution in the problem by identify start, input, process, output, and end. Use appropriate symbol to represent each step in the sequence. Use directional arrows to show the flow of the sequence of steps. And lastly, check that the flow of the solution is clearly communicated through the flowchart.
Now, considering the following program is read and draw the flowchart for its solutions. Savani bought a toy of 325 ringgit and sold the same of 458 ringgit. Explain how we can find if Savani is made a profit or loss.
In this problem, the goal is to find whether Savani makes a profit or loss.
We
We know the cost price and the selling price. We can read them as input, so they are represented as parallelograms.
Next, we have to compare selling price and cost price to find which price is more. This will tell us whether Savani has made profit or loss. How do we show comparison in the flowchart?
can you phrase this step as a question with the two possible answers?
We can ask a question, is selling price more than cost price? The answer to this question can be yes or no. If answer is yes, we have to calculate profit. And if answer is no, we have to calculate loss.
Right. In this step, you have two alternate actions that can be taken. The decision of which action has to be taken is decided by the answer to the question. The answer can be yes or no. This decision-taking step is represented as follows in the flowchart.
If the answer is yes, it means that selling price is more than the cost price and Savani has made profit. Profit is calculated as selling price minus cost price. If the answer is no, it means that the cost price is less than selling price and Savani has made loss. Loss is calculated as cost price minus selling price.
Good. You have used logical reasoning to solve this problem. Now draw the flowchart of how to find profit or loss. So here's the start. Read cost price equals to 325 and read selling price, the SP equals to 458. So is SP greater than CP? Yes, equals profit minus SP minus CP. And then of loss, CP minus SP, and then print profit. It is print loss and then stop. So profit SP minus CP equals print profit. So the output is Savani made profit of 133 ringgit by processing a profit, which is 458 minus 325 equals 133.
Here are the flowchart symbols and their purpose. The first geometry shape is ellipse. The purpose of it is start, end, stop, and exit, which means end. Secondly is parallelogram. The purpose is data, input, output. Rectangle stands for action, activity, and process. The diamond is decision-making step. Specify the question in the diamond. The next logical step is based on the answer yes or no to the question. And lastly is arrows. Arrows are used to connect the steps in the flowchart to show the flow or sequence of the problem-solving process.
Sometimes we need to repeat a sequence. How do we represent this in the flowchart?
Let us consider the multiplication table flowchart that you saw in the exhibition. See how repetition is represented in the flowchart. The flowchart or multiplication table for a given number n. So here start and the input is read number n. So its count equal to 1. And then here's the output print n equals the count. And here's the decision making step. Is count equals to 10? If no, we have to add once the current value of count, so it connects the start sequence to repeat the process until the print end count becomes 10. Well, when the count equals to 10, it's yes, and then stop, and then we are able to finish it.
The repetition sequence stops when count comes to 10. So here a decision structure has been used to start and stop the repetition.
Try out another problem to see how you can use such an assignment.
Let us draw a flowchart to find the factorial of a number.
How do you find the factorial of a number?
Suppose the number is 10, then factorial of 10 is calculated as 10 equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good. Draw the flow chart. So here's the factorial of n. So we start, input, read n, and here's the process which is set m equals 1, set m equals to 1. And then the next process is new value of m equals the current value of m multiplied by m. So is n equals to n? If no, we add once the current value of n. And then until it becomes 10, so that the is n equal to n, and then the factorial of 10 becomes 3,628,800. So we got the print loss, which is the output, and here's the end. Finish the flowchart. Good. From the examples that you have seen, can you summarize what are all the basic structures of representation?
In the addition of numbers example, we saw how to show a sequence of processing steps.
In the finding profit and loss example, we saw how alternate sequences can be specified using a decision box.
In the multiplication table and factorial examples, we saw how to show repetition of a sequence.
Flowcharts can be drawn for a problem-solving process using these three basic structures. For the first one is sequence. Sequence of steps are represented by symbols that follow each other top to the bottom or left to right. And next is selection. A condition or a question is specified in the decision box. Based on the evaluation of the condition, one of the logical steps is taken next. The next logical step can be a process, decision, or end of the flowchart. And as for repetition or looping, either the processing repeats or the control leaves the structure. If it is yes, you will have to just go down, and if it is no, it will just have to be on the right.
Good. Now let us consider a game. Do you know the game of snakes and ladders?
Yes.
Okay, draw a flowchart to see how the game is played. So in snakes and ladders game, they are usually 4 players. So let's start with the first player as he throw the dice, move his coin, and ladder on the snake head. It slides down to the tail of the snake and give dice to the second player. When the second player throw the dice, move his coin ladder at the bottom of the ladder. If yes, move up to the ladder and give dice to the third player. When the third player throw the dice, move his coin and if didn't reach the last of the game, no, and he give dice to the next player. And start the fourth player throw the dice, move the token, and he didn't do all the above except reach the last of the game, which is space 100. If yes, then he is the winner and the end. So the conclusion here is flowcharts are essential and useful in many parts of our lives. Flowcharts are represented in the daily lives, no matter where we are, where we work, or where we study, or how people do their work. There's always the uses of flowcharts. Different types of flowcharts are used for different purposes, as this is beneficial for education and occupation. Thank you, and I will see you again soon.
Thank you.
Thank you.
Bye. Okay. Okay. So okay.